कैपेसिटी। तो सबसे पहले हमने ये समझना है कि हीट कैपेसिटी क्या होती है। व्हाट इज हीट कैपेसिटी? सो एज द नेम स्पीक्स, इट इज द कैपेसिटी ऑफ अ बॉडी टू इंड्योर हीट। लाइक कोई भी ऑब्जेक्ट, कोई भी बॉडी अगर एक सर्टेन अमाउंट ऑफ हीट एब्जॉर्ब कर लेती है विदाउट राइजिंग अ टेम्परेचर, तो वो उसकी हीट कैपेसिटी के अंडर है। बट वी नीड टू डिस्कस द लिमिट ऑफ हीट कैपेसिटी ओवर हियर. So let's say if there's a body which has been provided with 78 kilojoules of energy and we don't have any sort of temperature change, but as soon as we provide 79 kilojoules, तो उसका temperature 1 degree Celsius increase हो जाता है. So that is what we call a heat capacity limit. तो heat capacity क्या होती है? वो temperature जहाँ पे आपकी बॉडी का टेम्परेचर राइज हो जाए, या वो हीट जहां पे आपकी बॉडी का टेम्परेचर राइज हो जाए बाय 1 डिग्री सेल्सियस. सो heat capacity is basically the amount of heat that would be required to rise the temperature by 1 degree Celsius. Now coming to the formula of it, it's Q is equals to C delta T. So C delta T का concept क्या है? We have Q over here, which is the energy supplied. Then we have C, which is representing the heat capacity. And finally, we have delta T. Delta is always used for change. जहाँ पे भी आप change को denote कर रहे होंगे या आप change को define कर रहे होंगे, तो आप delta का symbol use करेंगे. So you have got delta T, which means that you are finding the change in temperature, or you are using the change in temperature over here. Now, what we need to understand over here is that whenever we are like provided with a query of heat capacity, तो हमारे पास multiple set of values हो सकती हैं. आपने उन values को सही से judge करना है, and then you need to use them wisely. Like we have a question over here which is saying that a solid block which is heated from 20 degrees Celsius to 85 degrees Celsius. So the temperature is rising from 20 and going all the way until 85 degrees Celsius. तो हमने energy change इधर energy find करनी है. Like what was the energy that was supplied while the heat capacity was 2700 joules. So the heat capacity has been provided as 2700 joules per degree Celsius. तो अब आपके पास change in temperature कितना होगा? The change in temperature is going to be 65 degrees Celsius. As you can see, the initial temperature was 20 and the final temperature after heating the body is 85. तो आप 20 से temperature को rise कहाँ तक कर रहे हो? 65 तक. So the change overall is 65 degrees Celsius. Now the heat capacity has been provided as 2700 joules per degree Celsius, and we need to figure out the energy being supplied. Like अगर एक body का heat capacity है 2700 और आपने temperature rise करना है from 20 all the way until 85, what would be the amount of heat needed? So you would use the formula over here, which is Q is equals to C delta T. आपने Q figure out करना है. You have been provided with heat capacity as 2700 and the change in temperature was provided as 65. तो आपके पास लॉजिक कुछ इस तरीके से है कि जब भी कभी आप इस टाइप के क्वेश्चन सॉल्व करते हैं, व्हाट यू फर्स्ट नीड टू डू इज यू फर्स्ट ऑफ ऑल पुट अप द वैल्यूज, मार्क द फॉर्मूला. लाइक आप जो भी फॉर्मूला यूज करते हैं उस फॉर्मूला को लिखना लाजमी है. सो व्हेनेवर यू आर लाइक यूजिंग एनी सॉर्ट ऑफ फॉर्मूला इन फिजिक्स, आपने उस फॉर्मूला को डेफिनेटली लिखना है, क्योंकि फॉर्मूला के मार्क्स लाजमी होते हैं. So like if we discuss the marking scheme of this particular concept, तो उसकी marking scheme क्या बनेगी ये हम समझ लेते हैं यहाँ पे. So let's say if I have this question for 3 marks, the first mark is going to be rewarded over here. जहाँ पे आपने formula लिख दिया वहीं पे आपको 1 mark मिल जाएगा. So this would be your very first mark. Now since you were like putting the values and solving them further, तो आपको सेकंड मार्क रिवॉर्ड होता है वर्किंग पे. सो दिस वुड बी योर सेकंड मार्क. And finally, the third and the last mark will be rewarded on the answer. So if let's suppose you are like using a formula and you are putting the values correctly, लेकिन आपने solution में कुछ error कर दिया और आपका आंसर गलत आ जाता है, तो आपको formula का mark लाजमी मिल जाए. So that is why you need to make sure that whenever you are dealing with any numerical in physics, आप formula लाजमी use करें. Now moving forward, we have another question which is like asking the final temperature of a block supplied with 1 lakh joules at 20 degrees Celsius, while the heat capacity was 420 joules per degree Celsius. तो हमने इसे solve करना था. What we were provided with was heat capacity. I've used it over here as 420. The amount of energy supplied was 1 lakh. If you see, it's 1 lakh joules. So the value of Q has been provided as 1 lakh. अब आप change in temperature find करेंगे सबसे पहले. So the change in temperature turns out to be 238. Like initially the temperature was 20. You have risen the temperature by 238. So the overall final temperature is going to be 20 plus 238. क्योंकि आप 20 degree Celsius पर stand कर रहे थे, and then you increased the temperature by 238. So that is going to produce 258 degrees Celsius as the final temperature. तो इस तरीके से आपको twisted questions भी आ सकते हैं. Now moving forward, we have the next concept which is specific heat capacity. अब एक चीज आपने जो समझनी है वो ये कि जब भी कभी मुझे कॉन्सेप्ट पूछा जाए या मुझे कॉन्सेप्ट के रिलेटेड कोई न्यूमेरिकल आता है फॉर स्पेसिफिक हीट कैपेसिटी, तो यहाँ पे जो टर्म स्पेसिफिक है उसका मतलब आपने समझना है. सबसे पहले द टर्म स्पेसिफिक इज ऑलवेज डिनोटिंग मास. स्पेसिफिक का दूसरा नाम क्या है? मास. सो इट रिप्रेजेंट्स मास इन एनी केस. तो जब भी हम किसी चीज के साथ स्पेसिफिक जोड़ते हैं, हम बेसिकली उसको मास के हिसाब से कंसीडर करना शुरू कर देते हैं. सो इफ वी हैव स्पेसिफिक हीट कैपेसिटी, नाउ वी वुड चेंज द डेफिनेशन स्लाइटली, और अब हम कहेंगे कि हीट कैपेसिटी इज द हीट नीडेड टू चेंज द टेम्परेचर बाय 1 डिग्री सेल्सियस. यहाँ तक तो हमने पढ़ा था पहले भी दैट हीट कैपेसिटी इज द heat required to change the temperature by 1 degree Celsius. लेकिन अब यहाँ पर कुछ एडिशंस हैं because of the term specific. तो अब आपने specific की वजह से यहाँ पर लिखना है for 1 kg of mass. So specific heat capacity is when 1 kg of a block is heated by 1 degree Celsius. तो आपने जितनी भी एनर्जी सप्लाई की है for that 1 kg to have a rise of 1 degree Celsius, that energy is termed as specific heat capacity. अब आ जाते हैं इसके फॉर्मूला की तरफ. The formula is almost exactly same. Its Q is equals to mc delta T. तो यहाँ पे आपके पास Q पहले भी था heat capacity में. You had C and delta T as well. The only difference is of mass. If you see over here, the M is now an extra thing. क्योंकि आप specific heat capacity में हैं, तो आप M को भी consider करेंगे. Now what you need to do is that you need to like solve numericals for these particular formulas. So let's say if I'm saying that Ali heated a block of 4 kg by 70 degrees Celsius. Find the energy if the specific heat capacity is equal to 400 joules per kg degree Celsius. Okay, so we have our values over here. The block was having a mass of 4 kg. The change in temperature is 70 degrees Celsius. We have been provided with a specific heat capacity as well, which is 400. We need to figure out the value of energy that is being given in. तो हमारे पास formula है Q is equals to mc delta T. Now, can any one of you solve it and tell me the answer? Yes, what would be the energy supplied over here? Yes, anyone who has got the answer over here? Mass is 4 kg. We have got the heat capacity as 400 and the change in temperature is 70. So what's the final answer for the heat supplied? Anyone? Okay, so it's 112 with 3 zeros. And the SI unit would be joules. The answer for heat supplied to this particular block to rise its temperature by 70 degrees Celsius, having 4 kg of mass with a specific heat capacity of 400 joules. So heat supply kitna hai? 1,12,000 joules. Now we are moving forward. We are going to do a similar question. This one says that boy heats water by 30 degrees Celsius, while the specific heat capacity was 1500 joules per kg degree Celsius, and the mass was 18 kg. Find the heat supplied. We need to figure out the heat that is being supplied over here. The amount of temperature change is 30, while the mass is 18 kgs, and the heat capacity or the specific heat capacity is 1500 joules per kg degree Celsius. हमें energy find करनी है. The formula is going to be Q is equals to mc delta T. और यहाँ पर एक बहुत इंपॉर्टेंट चीज जो आप लोगों ने याद रखनी है वो ये that whenever you are provided with the mass in a specific heat capacity or a heat capacity question, तो अगर आपके पास mass given है and then they are talking about this particular concept, तो आपने specific heat capacity का ही formula use करना है. So you need to use the formula of specific heat capacity over here as well, और इसको use करके मुझे अपने answers बताएं, all of you. The mass is 18, change in temperature is 30, and the heat capacity is 1500. Okay, so we have the first answer as 8,10,000. Okay, are all of you getting the same answers? Huda, Husna, Ramsha. Okay, so since all of you are getting the same answer, we are now moving on to a different question. और एक चीज बहुत इंपॉर्टेंट आपने यहाँ पे याद रखनी है that whenever you are solving any particular question in physics, तो आप लोगों ने यूनिट लाजमी लिखना है. तो ऐसा यूनिट इज कंपलसरी. अगर आप ऐसा यूनिट नहीं लिखते हैं तो फिर बड़ी प्रॉब्लम हो जाएगी, एग्जामिनर नाराज हो जाएगा और फिर एग्जामिनर ने हमारा पेपर आग लगा देना है, पेपर को जला देंगे एग्जामिनर भाई. उनको ऐसा मौका नहीं देना है हमें. तो अब आ जाते हैं नेक्स्ट क्वेश्चन की तरफ. Bowl of water was heated with a burner at 2800 joules in 50 seconds. find the time needed to raise the temperature by 80 degrees Celsius for 2 kg at the specific heat capacity being 2000 joules per kg degrees Celsius. Okay, so this is a past paper question और इस क्वेश्चन के लिए एग्जामिनर रिपोर्ट के मुताबिक ज्यादातर स्टूडेंट्स वर लाइक अनेबल टू सॉल्व दिस या फिर उन्होंने वैल्यूज गलत यूज कर ली थी. तो एग्जामिनर भाई जो हैं वो हर साल, because I have already discussed what the examiner reports are, I'm again going to tell you people that the chief examiner is like every year generating a sort of report on the paper. तो हर सब्जेक्ट की एक एग्जामिनर रिपोर्ट चीफ एग्जामिनर फॉर दैट पर्टिकुलर सब्जेक्ट रिलीज करते हैं हर साल और वो डिस्कस करते हैं अबाउट द कॉन्सेप्ट्स that were like manipulated or misused by the students or the concepts that were missing overall. Like in general बात हो रही होती है तो चीफ एग्जामिनर डिस्कस करते हैं उन क्वेश्चंस को जहाँ पे स्टूडेंट्स ने प्रॉब्लम्स की, जहाँ पर स्टूडेंट्स के एरर्स थे या जहाँ पे स्टूडेंट्स ने बहुत अच्छा परफॉर्म किया. तो इस क्वेश्चन के लिए चीफ एग्जामिनर ने कमेंट्स दिए थे that this question was like a very difficult question for most of the students because they either were unable to solve it or were using wrong values to solve it. तो अब हम समझ लेते हैं कि इसमें कौन सी वैल्यूज कैसे यूज होंगी. So first of all, a burner is heating a bowl of water and the energy supply is 50 seconds with 2800 joules. Like in every 50 seconds, the energy supply is 2800 joules. तो हमने ये find करना है that what would be the amount of time required to heat this particular bowl of water by 80 degrees Celsius, having the specific heat capacity as 2000 and the mass as 2 kg. So we have got the change in temperature, we have got the mass, we have got the specific heat capacity as well. तो आपने specific heat capacity का फॉर्मूला यूज करते हुए सबसे पहले फाइंड करनी है एनर्जी, because we need to figure out the time. Like हमें ये पता है that 2800 joules is being provided in 50 seconds, but we don't know the amount of energy that would be needed to like rise the temperature by 80 degrees Celsius. तो हम सबसे पहले वो energy figure out करेंगे. So what we first need to do is we will use 80 degrees Celsius, 2 kg and 2000 joules per kg. तो आपने ये सारी values use करनी है. It is going to be 2 times 80 times 2000. Can anyone of you tell me the value? Okay, so it's 3,20,000. And that is with joules. तो energy कितना supply हो रहा है for 80 degrees Celsius of rise? The energy supply is 3,20,000 joules. And now we already know that for 2800 joules, the time needed was 50 seconds. And I need to figure out the amount of time required for this much energy. Now we need to use the concept of cross multiplication over here, और अब हम करेंगे cross multiply. So we will be having 2800 times x is equal to 3,20,000 times 50. और अब आपने इन्हें सॉल्व करना है. You'll have x over 3,200,000 times 50 over 2800. Okay, so we have the answer as 5714. Can anyone of you also confirm this? If the answer is 5714, or is it different? Okay, so we have 114 as well. Anyone else who could solve this and tell me the answer? Okay, so we are having 5714. When you are getting the wrong answer, it's 5714. Now, we are going to do a similar question of this type, and we will see if you people are able to do this or not. So, a plastic bag is heated at a rate of 3000 joules per minute. We need to find the time needed to raise the temperature by 30. We need to raise the temperature by 30 degrees Celsius. If the mass is 8 kg and the specific heat capacity is 1000 joules per kg degree Celsius. तो हमने इसे सॉल्व करना है. We need to find the time needed to raise the temperature by 30 degree Celsius. 30 degree Celsius हमने टेम्परेचर को रेज करना है for a mass of 8 kg with specific heat capacity of 1000. और फिर टाइम कैसे फाइंड करेंगे? इस वैल्यू सेट को यूज करके. So we have 3000 per minute. 3000 joules per minute है. फिर हम रेशियो बनाएंगे और सॉल्व करेंगे. सबसे पहले आप मुझे एनर्जी रिक्वायर्ड बताएं यहाँ पर कितनी होगी. What will be the amount of energy required over here? The formula is going to be of specific heat capacity because mass is being included over here. So it turns out to be 2,40,000. बाकी सबने भी confirm करना है if you are getting the same answer or are you getting a different answer? All of you need to confirm this. Okay, since all of you are getting the same answer, we are now moving on to the next step. और अब नेक्स्ट स्टेप ये है कि आप लोगों ने the next step over here is that you people need to solve this और आप लोगों ने टाइम फिगर आउट करना है. So for 3000 joules it was 1 minute required. You need to find the time for this much energy. इसे सॉल्व करें और अपने आंसर्स बताएं, ऑल ऑफ यू. Okay, so we have got 80 as our answer. Perfect. So all of you are getting the same answer. We are now moving forward. और अब हम चलते हैं latent heat की तरफ. So we have the next concept of latent heat of fusion. Latent heat of fusion क्या होती है ये हमें समझना है. Okay, so latent heat of fusion is basically the amount of heat required to change the state from solid to liquid. अब इसको याद करने का तरीका क्या है? If you ever see latent heat, तो जैसे मैंने आपको कहा था स्पेसिफिक के लिए आपने मास को याद रखना है, तो latent heat के लिए आपने चेंज ऑफ स्टेट को याद रखना है. तो जब भी लेटेंट हीट की बात होगी इसका मतलब है दैट वी आर डिस्कसिंग चेंज ऑफ स्टेट, वी आर कंसीडरिंग ओनली द कॉन्सेप्ट ऑफ change of state under latent heat. So this is going to be the heat needed to change the state from solid to liquid. Okay, so what happens over here is that since we are discussing latent heat, तो latent heat का मतलब क्या होता है? Change of state. अब फ्यूजन जो आपके पास लिखा हुआ है latent heat के आगे, इसका मतलब क्या है ये समझ लेते हैं. So fusion means that the particles are colliding together. So in fusion the particles would always be colliding. तो आपने याद रखना है कि सॉलिड्स में पार्टिकल्स कोलाइड नहीं होते हैं, बट नाउ दे आर कोलाइडिंग. सो वी आर बेसिकली मूविंग फ्रॉम सॉलिड टू लिक्विड, क्योंकि हमें एक ऐसी स्टेट में जाना है जहां पे पार्टिकल्स कोलाइड करते हैं. इवन इन गैसेस द पार्टिकल्स वुड मूव अवे, दे वुड नॉट कोलाइड टुगेदर. ओनली इन लिक्विड द पार्टिकल्स आर कोलाइडिंग. तो आप इस तरीके से इस डेफिनेशन को याद रख सकते हैं. नाउ वी नीड टू अंडरस्टैंड द concept of latent heat of fusion with respect to the energy. तो energy के हिसाब से हम इसे जरा समझ लेते हैं. So let's say if I have provided 7,000 joules to a glass of water filled with water completely. तो इस गिलास को हमने completely fill कर लिया था with water and the energy was supplied as 7,000 joules. But there was no change at all. लेकिन जैसे ही हमने एनर्जी को इंक्रीज किया एंड वी सप्लाइड लेट्स से 7,001 जूल, तो अब 7,001 पे जो हमारे पास ग्लास ऑफ वाटर है इसमें से वाटर एवोपरेट होना शुरू हो गया. सो द वाटर स्टार्टेड टू एवोपरेट और बॉयल एंड देन दिस पर्टिकुलर कॉन्सेप्ट इज द चेंज ऑफ स्टेट. तो इसी को अगर हम लेटेंट हीट ऑफ फ्यूजन पे अप्लाई करें तो हमारे पास यहाँ पे ग्लास ऑफ वाटर की जगह पे कोई सॉलिड आ जाएगा. सो इट वुड टर्न आउट टू बी लेट्स से आइस. और आपने आइस को जब एनर्जी सप्लाई की है तो आपने देखा दैट until you were providing 7,000 joules there was no change to ice, the state was not changing. But as soon as you provided 7,001 joules तो आपने देखा कि स्टेट चेंज होना शुरू हो गई है एंड देन आइस कन्वर्टेड इनटू लिक्विड वाटर. तो ये पूरा कॉन्सेप्ट है लेटेंट हीट ऑफ फ्यूजन का. और अब हम कहेंगे दैट द लेटेंट हीट ऑफ फ्यूजन फॉर आइस is 7,001 joules. So this is the concept of latent heat of fusion. I need a confirmation from all of you if this is perfectly clear, or do you have any sort of query in this? Yes, is it perfectly clear to all of you? Okay, I'll explain this again. Look, first of all, the term latent heat is basically the heat required to change the state. Latent heat का मतलब क्या है? Change of state की बात हो रही है. So if we are discussing latent heat, that means we are discussing change of state. And latent heat of fusion means the state is changing from solid to liquid. The state has changed from solid to liquid. So this is latent heat of fusion. Like it is the amount of heat required to change the state from solid to liquid. So that's exactly what the definition is. Now coming to the concept of latent heat with respect to energy. तो अब energy के हिसाब से समझ लेते हैं. Like if I had a piece of ice over here and I was supplying 7,000 joules to it. मैंने आइस को कितना एनर्जी सप्लाई किया है? I have supplied 7,000 to it and there was no change at all. There was no change. 7000 joules पे हमें कोई change नजर नहीं आया है. Suddenly I increase the amount of energy supply to 7001 joules. तो जैसे ही मैंने 1 जूल एक्स्ट्रा सप्लाई किया तो मैंने देखा that 7001 joules was the point where ice started to convert into liquid. और यहाँ पे जितनी भी ice थी it gradually reduced to liquid. So I would say that latent heat of fusion for ice is 7001 joules. अब क्लियर है या अभी भी कोई क्यूरी है? हुदा, मिना, are you both clear now or do you have any sort of query? Okay, now we are moving forward to the next concept, which is very much similar to latent heat of fusion, and it is latent heat of vaporization. तो latent heat of vaporization को समझ लेते हैं. तो आप में से कोई latent heat of vaporization की definition guess कर सकता है? Can anyone of you tell me the definition of latent heat of vaporization? Okay, so it is the heat needed to change the state from liquid to gas. Very good, Meena. Okay, Uday, you are very close. It's like the state change towards gas. लेकिन हम कभी भी गैस को डायरेक्टली सॉलिड में से कन्वर्ट नहीं करते हैं. Like we don't convert solid directly to gas in vaporization. Like vaporization is like evaporation. आप अगर evaporation का concept देखें तो आप liquid को convert करते हो गैस में. So you are not converting solid into gas directly. You are converting liquid into gas. So that's the concept of latent heat of vaporization. So we would say that it is the heat needed to change liquid into gas. Okay, so this is very similar to latent heat of fusion. अब यहाँ पे हमें दोबारा से समझने की जरूरत नहीं है बिल्कुल भी. The only difference is that now we are converting liquid into gas. Previously we were converting solid to liquid. Now we are converting liquid into gas. तो बस ये आपने याद रखना है. The other things are exactly same with no difference at all. तो ये हो गया हमारे पास latent heat of vaporization. Now we are moving on to the very last concept of this particular thing, which is basically specific latent heat. So we have specific latent heat of fusion. Now, can anyone of you guess what does the term specific means? Specific का क्या मतलब बताया था मैंने आप लोगों को? What was the meaning of the term specific? Mass. Very good. So we would say that specific latent heat of fusion is the amount of heat required to change the state of a solid into liquid for 1 kg of mass. So we will say that it is the heat needed to change solid into a liquid having 1 kg of mass. Now what we see over here is that the concept of specific and the concept of latent heat have merged together. तो specific का concept था mass से related और latent heat का concept था अपना like change of state से related. So we have got the change of state, we have got 1 kg of mass, and since it's latent heat of fusion, so we are converting solid into liquid. So latent heat of fusion with the term specific is defined like this. Specific latent heat of fusion is basically the amount of heat needed to change the state. So it is the like heat required to change state from solid to liquid having 1 kg of mass. तो इस तरीके से हम डिफाइन करते हैं. इसके लिए एक फॉर्मूला है हमारे पास एक्स्ट्रा, वो फॉर्मूला आप लोगों ने याद रखना है because it somehow comes up in our numericals as well as MCQs. तो हमारे पास फॉर्मूला है E is equals to ml. Now what you need to be aware of is that E over here is energy, like the heat which is being supplied, then M is your mass, and L is the latent heat. So whenever you are like dealing with latent heat, it could either be considered as latent heat of fusion or latent heat of vaporization. आप लोगों ने टेंशन नहीं लेनी है. L is basically used unanimously for latent heat of fusion as well as latent heat of vaporization. We are going to do a numerical for this and then we'll wrap up this chapter. So a stick of iron, no, it cannot represent liquid. L is for latent heat only. Liquid को represent नहीं कर रहा है. A stick of iron is melted to form molten iron. Find the heat needed for 7 kgs with latent heat equivalent to 700. Now we have got the latent heat as 700 joules per kg, and we have got the mass as well. We need to figure out the energy. We have the formula over here, E is equals to ml. ये formula ही use करना है आप लोगों ने और मुझे आंसर बताना है. So you need to solve and tell me the answer. All of you, जल्दी से solve करें और आंसर बताएं. Okay, so the answer turns out to be 4900 and the unit is mandatory. It's 4900 joules. तो ये हमारे पास आ गया है energy. Now we are discussing the very last and the smallest concept out of this chapter, and that is bimetallic strip. तो bimetallic strip को discuss करते हैं और फिर chapter खत्म. So bimetallic strip is basically a strip of metals, and as the name speaks, it's bimetallic. Bi means two and metallic means metal and strip. So it is a strip of two metals, like it is a strip of two different metals that are attached together. अब पॉइंट ये है कि हम इस बायोमेटेलिक स्ट्रिप को यूज कहाँ पे करते हैं. वेयर डू वी यूज दिस बायोमेटेलिक स्ट्रिप? सो वी यूज दिस स्ट्रिप to control temperatures. We use it to control temperatures. Now the point here is कि temperature control करने में कैसे use होती है. So I'll give you an example with a figure and you would have an idea कि हम इसे कैसे use करते हैं. So let's say if I have two different metals over here in the form of a strip, और इन दोनों ही मेटल्स को हमने हीट करना शुरू किया है. Like there's a burner over here and the switch of this burner is placed over here. This is the switch for the burner. Now, as soon as you are supplying the heat from the other side, let's say from this side, the metal is going to expand on that particular length. तो अब होगा कुछ ऐसे कि आपका जो metal strip है, it would change its shape like this. The metal strip will change the shape like this. And now you will see that the connection with the switch has now been dismantled. यहाँ पे जो हमारे पास स्विच था, अब उसके साथ कनेक्शन रिमूव हो चुका है. The connection has been removed. So we would say that now the switch is turned off. Will now the heat be supplied over here? क्या अब भी हीट सप्लाई होगी या स्विच ऑफ होने के बाद हीट सप्लाई रुक जाएगी? What do you people think? Will the heat be supplied or will it stop now? Yes, any idea? Since the switch is turned off, will the heat be supplied anymore or will it stop now? Exactly, there won't be any heat supply. Now what was happening is that we had a metallic strip over here and it was having a switch and the heat was supplied from this particular corner. This switch was for the heat supply. Now, as soon as we are supplying heat, the metallic strips bend upwards, like ये upward bend हो गई है, and the connection with this particular switch is now removed. Connection remove हो चुका है. So will the heat be supplied over here or not? That was my question. So since we have turned off the switch, there won't be any heat supply. So we can say that this particular mechanism can be used to control temperatures as well as burners and heaters. तो हम इन सारे ही apparatuses के अंदर इस bimetallic strip को use कर सकते हैं. Now the point here is कि इसका question कैसे आता है? The examiner could ask you about which metal has expanded more and which one has expanded less. So let's say if this was metal A and this one was metal B. इन दोनों के हमने नाम रख दिए as metal A and metal B. What we have got over here is that metal A is moving upwards like this and metal B is also moving upwards. लेकिन एक definite change आपको नजर आएगा that metal B has stretched a bit more. If you can see, both of them were of equal length initially. लेकिन जैसे ही आप हीट सप्लाई करते हैं, आप देखते हो कि metal A is not that much long now, but metal B is much longer than metal A. Length में increment जो है B metal में ज्यादा हो गया है. So we can say that metal B has expanded more compared to metal A. Now this was the only concept related to metallic strip. आपने सिर्फ ये guess करना होता है that which metal has expanded more and which metal has expanded less. Now I'll give you two types of metal expansions and you would have an idea कि किस type के questions आते हैं और हमें कैसे judge करना है. So if I have two metal strips like this, I would say that you need to make up a circle. Like आपको दो metallic strips दे दी गई हैं, आपने इनका circle complete करना है. So you would see that the green circle would look like this, while the blue circle would be larger. Agreed or not? Green का अगर मैं circle complete करता हूँ तो वो definitely छोटा होगा और blue का circle enlarged होगा. It would be greater in size. Are you perfectly clear on this? ये इसमें कोई query है? Yes, I need a confirmation before moving further. We were provided with two different metallic strips. The first one was blue and the second one was green. हमने क्या करना है, हमने blue का circle भी complete करना है like this, and we need to complete the circle for green as well like this. You would definitely see a clear difference that the blue circle is larger compared to the green circle. So we can straight away say that since the blue circle is larger, the blue metal has expanded more and the green metal has expanded less. तो इस तरीके से आप ट्रिक यूज करके जज कर सकते हो which one has expanded more and which one has expanded less. Now I am giving you a similar query and you people need to solve this. We have a white and a yellow metal. आप लोगों ने ये जज करना है that which metal is going to expand more and which metal is going to expand less. Same concept use करना है circle वाला और जज करना है which one is expanding more and which one is expanding less as well. तो जल्दी से इसे चेक करें और मुझे बताएं which metal has expanded more and which one has expanded less. Very good. So all of you are getting the same answer. That's really good, all of you. And we are now perfectly done with all the concepts related to heat capacity. तो आज हम इसको wrap करते हैं. You people would now be receiving the past papers, inshallah, either by tonight or tomorrow morning. तो संडे की क्लास से पहले आप लोगों ने वो past papers complete करने होंगे and you need to submit those solutions to me personally. Like मेरा जो personal WhatsApp है उस पे आप लोगों ने मुझे send करनी है सारी solutions for all the past papers. So we'll wrap it up today. But before leaving, I want a confirmation from all of you if all of the concepts were perfectly clear or not. हमने जितना भी आज पढ़ा है सब कुछ clear है? Okay, so that's a wrap for today. See you people in the next class. Take care everyone. Allah Hafiz.